To begin with, we'll be learning what a network is. A network can be best explained as a group of computer devices connected to each other so that they'll be able to exchange data with each other. A network can be best explained as a group of computer devices connected to each other in order to be able to exchange data with each other. Every device on the network can be imagined as a node, as a point where the devices in the network are able to send and receive data from each other. A node, simply put, is an endpoint for receiving or downloading the information, and each node has a unique address. This address is known as IP address. Only the devices in the network use IP addresses for communication. For humans to identify devices, we can assign names to these addresses. Think of wikipedia.com. If I were to ask you what's the IP address of wikipedia.com, chances are you don't know the Wikipedia server IP address. However, if you wanted to look something up on wikipedia.com, if you were to access Wikipedia, you simply type wikipedia.com in the web browser. In this case, we assigned a name to an IP address to make the identification process a whole lot easier for us humans. In the following slides, we'll learn more about the IP addresses, DNS, ports, and data transmission. In the previous slides, we talked about IP addresses, how they are used by devices on the network for communicating with each other. But what are they in the first place? At its most basic, an IP address is a string of numbers assigned to internet connected devices, to network connected devices. Think of the IP addresses as a house addresses. If you were to place an order online, in order to receive the package from the seller, you have to provide your address. Similarly, your computer network uses IP address to communicate with other computer devices on the network in order to send and receive information packets. An IP address consists of 32 bits, but it's often shown as 4 octets of numbers from 0 to 255 number range, represented in decimal form instead of the binary form. For example, the IP address 168.212.226.204 in binary form is shown on the right. Now, which one do you think is easier to read, the 4 octets or the binary form? I'd go with the octet form. Moving on, what can we learn from an IP address on the web? IP addresses can reveal the details such as the city, zip code, and area code where the device is operating from. Other than devices on the network, other entities can also track your device using the IP address. Authorities use IP addresses to piece together information of the devices on the network in case there's any illegal activities. Employers also use the IP addresses to see where you're spending time online at work. As work from home is slowly turning into a more permanent means of working, employers want to understand which location you are working from and where you're spending your time online at work. IP addresses can also be used to only allow the authorized devices as a form of security control. We'll learn more about this later. Advertisers also use IP addresses. They use trackers to keep track of your web activity in order to build a profile on you and target you with personalized ads. Last but not the least, cybercriminals try to learn your IP address in order to launch cyber attacks against the device you are using. By now, we learned everything we need to know about what an IP address is. Moving on, now we'll learn about the Inter-NIC register. This is the organization that's responsible for the allocation of IP address ranges to computer networks. When allocating these IP ranges, they consider certain criteria such as the geographical area, the organization or enterprise involved, and the host. Now we'll be learning about the domain name system, DNS in short. Earlier we discussed how names can be assigned to IP addresses to make it easier for us humans to remember web addresses. Instead of typing website IP address, we simply enter the web address and access the website. Now, what we need to be asking ourselves is, who keeps track of these names of websites and the IP address of these web servers. If you enter the web address of Wikipedia, you are able to access Wikipedia and not YouTube, correct? So there must be a list of sorts linking them, right? Yes, the answer is DNS. DNS servers are the ones responsible for translating the web addresses into numeric IP addresses. Domain name system maintains a list associating the web addresses and the server addresses. So far we learned about the IP addresses, DNS, and how IP address are used for identification purposes. But now what's with the IP port? Internet Protocol port. Just like how IP address helps in communicating with different devices on a network, ports also help the devices on a network in deciding which internet protocol has to be used to decide what to do with the internet traffic. We'll learn more about the internet protocols in the upcoming videos. For the time being, what we need to remember is that an IP port will identify which internet protocol has to be used to deal with the incoming traffic. Similar to IP address, even these IP ports are identified or associated with a port number. Some port numbers are dedicated for specific applications. For example, the file transfer protocol uses port numbers 20 and 21. The SMTP protocol uses the port number 25. HTTPS protocol uses the port number 443, and so on. IP addresses are used for the identification and IP ports are used to decide which protocol has to be used in order to decide what has to be done with the incoming network traffic. Which protocol has to be used to decide what to do with the incoming network traffic. Now that we have a clear idea about those two, let's learn how data is transmitted in a network. When data is sent and received between devices, this data is first broken down into data packets. Then these data packets are sent to the recipient device. The recipient device collects these packets and then checks if all data packets have been received, and then reconstructs the original data or the original message. Each data packet has a maximum size and consists of a header and data area. This header, it also contains the address of the source and destination computers. It also contains the data necessary for reconstructing the data after the data packets have been received by the destination computers. What we learned so far? We've learned what a computer network is, what an IP address is and its purpose. We learned about the domain name system, IP ports and their purpose, and how data is transmitted in a network. In the next video, we'll learn more about the different types of networks.